Welcome to Python Basics with EJE. We are gradually coming to the end of object-oriented programming. It's been a nice one. After this, I have one more video on object-oriented programming, and then we'll move on to something else in the playlist. So in this video, we'll be looking at advanced object-oriented programming features in Python, advanced OOP features in Python. Okay, so the goal here is to dive deeper into real-world object-oriented programming concepts in Python. And by the end, you'll be able to decide between composition and inheritance, design and use mixins with multiple inheritance. You can implement Dunder methods like double underscore len, double underscore contains double underscore call double underscore. Effectively, we saw things like this in the previous video. And then we have the composition versus inheritance. That's the first thing we are looking at. So talking about inheritance, we have that means is a something. So that talks about subclass. So in this case, subclass specializes a base class and use when the child is truly a subtype, right? So that's the child class is a subtype of the parent class. Then you have the composition, which is has a. So you have the class contains another class, and you use it for flexibility and loose coupling. So you should prefer composition when you want to swap parts easily, like plug and play. You want to avoid rigid hierarchies and you need runtime variability. So avoid using inheritance only for code reuse. So, okay, I needed to delete this. Yep, just delete. Okay, so we have an example here. We have a car engine talking about composition over inheritance. Okay, so from ABC, import ABC and abstract method like we saw in the last video. So you have the class engine, that's the parent class engine of ABC, right? So you have abstract method, which is start, stop, and status. So you have three different abstract method functions like that. Start, stop, and status. And this status thing is string, so it means you're going to tell a story. Then you now have class petrol engine. So you see petrol engine is a child class that inherits the characteristics of the engine class, which is the parent class. Then you now have define double underscore, you need double underscore self cylinder. So you have a default value of 4 cylinders. So it means you can have more than that or so, or less than that. But it is actually by standard, it's 4 cylinders. Okay. In that case now, um, okay. So in that case, now we have self dot cylinders equals cylinders, then self dot underscore running. So this automatically is a what's this class now? I think it's what we have three types of class. You have public, we have private is the last. There's one in between, which I've forgotten now. I think it's protected. Yeah, this is protected. Single underscore. So this is protected. Then we have define start, stop, status for all the self dot underscore running equals true. For stop, self dot underscore running equals false. And for the status itself now, we have so for the status, we have return petrol engine, whatever number of cylinders, running, self-running, like that. So and then we also have a child class called electric motor, which inherits the attributes of the engine parent class. Then again, this one talks about power, power in kilowatts, and the default is 100. Then you have the power defined, you have the running false. Then you also have the start stop status like that, true running, and then electric motor with this particular power in kilowatts running, whatever self-running that is, whether it's true or false and all that. And you also have a class called car. So this is a totally different class now. And it seems that it has nothing to do with the previously defined classes, except that we can now make it inherit the characteristics of the other subclasses defined. So we define this class now with three attributes. You have engine. So, okay, yeah, we still have the whole engine thing here. Engine label string. So self-engine is engine. That's composition right here. Then self.label is label. So start, stop, and the whole string thing. We have that. So you can study this better. So car one now is the car class inheriting petrol engine. And of course, the petrol engine class takes cylinders, while the other one takes kilowatts, the power, right? So you have car inheriting petrol engine with 6 cylinders, and this is 150 kilowatts. So, and this is sedan X for the car one. Car two is EVZ. So if you now do car one dot start, car two dot start, and you now print car one, car two, see what you get. This is our first thing we're running, so that it takes a bit of time when we work on the first one. So here now you see sedan X, petrol engine, 6 cylinders, and it is running. Then EVZ, electric motor, 150 kilowatts, and it is also running. So that's what that does for us right there. Then we have mixins and multiple inheritance. So what are mixins? So they are small reusable classes, and they provide behavior, not identity. And they are named with mixing suffix, right? So it means they end with mixing. So when you see mixing at the end of it, these are small reusable classes that provide behavior with not identity and use cooperative supercalls to work with MRO. So multiple inheritance in Python now. So for multiple inheritance in Python, this uses C3 linearization, talking about MRO, and it ensures every class is initialized once. So we have an example right here. So talking about mixins in action, we have this code like this. So example of mixing in action, you import datetime as DT because you need that date. So you have class timestamped mixin. So that's the suffix now. So you define so you can take multiple arguments, whether keyword argument or regular argument. So self created at datetime this. So you can study this better. Then you now create another class called REPR mixing. Okay. And then you have so here you are working with some kind of string, so you are joining things together. So when we work with string, you could see the join is to join things up with strings. Then you have savable mixing. So you also have saved whatever class with datetime in that format. Then you have the base model. I'm just running through it because just look at the code and sit with it, try to tweak and see what happens. You have the base model also. We can take multiple arguments, multiple arguments and multiple keyword arguments. Then you now have a class called user that takes in all the classes that have been defined before. The timestamped mixing, the REPR mixing that you did for savable mixing and base model. And this one has two arguments, username and mail. So you can have, of course, this is a generic mail. It's not any particular mail. So it's just for example. So you have A is user, you have Alice. So Alice at example.com. So you print that and you save and all that created. So if you run this, it takes not too much time, and we have result like this. So you have the username Alice, the email is given, created time 2025, 23, and you have all of these things going. Saved user, the date and all that. So the date is created too, and you have all of this. So you can see through that better for clearer understanding. So we have the magic methods, which you can call Dunder methods. So Dunder methods make objects act like native types, right? So you have double underscore, len underscore is the same as, goes to length of the length of the object, then contains, talks about whether X is in the object, so you have double underscore, double underscore, going to the object and three. So you have instance as a function. So some design tips, you can keep semantics predictable and avoid side effects. Okay, so here, using len double underscore, len double underscore contains and call like that. So you have class tag bag. Okay, you have class tag bag, and in that case now, it takes multiple tags, I believe, because of this star. So you have self dot under, so it's a protected kind of variable or argument, if you like. Then you define all these functions. So len contains call with all the tags and all that and all that. So to now call that, you can say you have TB, which is tag bag. Then you want Python for the tag bag, right? You want several variables. So you have Python, OOP, mixins, and Dunder. Then you can print length of TB. It tells you the length. You print OOP in TB. If is OOP in TB, of course we see OOP is right here. Then you print TB is DU. That's the call now. And TB.add, you have doc typing. And then when you print the TB, see what you get. So here now, so what's the first thing? You print the length of TB. That means you have 1, 2, 3, 4 things, right? There, which is okay. Then the next thing is OOP in TB true, right? What if I change it to OOPL? That's going to turn to false. So you see the true turns to false. But OOP is right here. That's why that is true. And then for the tag bag now. So after adding, so by using tb.add doc typing, now you now have doc typing added to it. So by the time you check the length again, it's 5. So you have Python, OP, Mixins, Dunder, and doc typing. So let's do a mini project where we deal with a library management system. The requirements are you want to use composition for catalog and loan manager, and you want to implement Dunder methods. Set length for number of book, contains for check if book slash SD ISBN exists, and call for quick search by method. Then use at least one mixin like timestamp mixin or RAPR mixin. Okay, let's talk about the models. So from data classes, you import data class, you import field. From typing, you import dict, list, and optional. Then you create the class timestamped mixin. So you define that. So it takes multiple arguments, as you can see, the ags and quags. So import data as DT under that self-created. So this talking about timestamps, right? When you borrow the book, when you return the book, and things like that. So you talk about the RAPL mixing. So you may want to understand this better. So you can dig further to see what all of these things are about. Then you have the data class, so frozen true. So you now have the book class now. ISBN is string, title is string, author is string, year is integer, tags is tuple, like field, default factory is tuple. Then you have the data class. So you have class member ID is string, name ID is string. So if you run this, of course, you don't expect to get a result yet, but it's been run. You have the check. So you can see we haven't run this other one. That's why there's no check mark beside it. Then for the catalog call, right? You have class catalog timestamp mixing. So you use the mixing here, and then you define this. You have self book. So it's a protected thing because nobody should just have access to it like that. And this one now is inheriting things from the this timestamps mixing and rep mixing are classes. So catalog is inheriting the timestamps and all the RAPR. So that's why you have this super. We talked about this super thing, talking about a child class inheriting from parent class like that. Then here now you define add. So add takes it takes book as an argument. So you have book self with protected books, book ISBN, you find that. Then you also have remove get and all with all the IS. So this ISBN for these two, and then you have the self also for all, right? So you do the learn, the content, and the call. Like I said earlier, you want to study this for clearer understanding. So this has been run now. So we now go for the loan manager too. So for the loan manager, we have the loan manager class is inheriting timestamp mixing and rep mixing. So you have protected loans, right? Because you have a level of protection to that. If you want to borrow a book from the library, then you also have the checkout, like when you finally decide on the books to go for. So if ISBN is in self.loans, return false. So if the book is there, you want to find out. If it is not there, you want to find out so you can know what you want to check out or not. So then you also have check-in. Maybe you want to return the book. So you go for all this now. Then you have the borrower, you have the loan, you have the learn and content. So you want to study this more. So I run this now. So this has been run, but we don't have the result yet. I think okay, we still do another cell before we get to where we run to see what the result looks like. So this is looking at like a lot, but if you sit down with it, you get the gist. So library, you have the composition. So class library, timestamp mixing, RAPR mixing. So this one takes a name, which is string by default. So you have self.name is name. Then the catalog that we talked about previously, because this library is still inheriting all these things. So you have the catalog loans. This is referring to the loan manager, then the members. Then this still inherits something from previous ones, like we said. Then you define add book, remove book. If somebody so cannot remove loan book. So if the book is already loaned, you can't remove it because it's not there in the first place. Then register member. So you can register a member. You can do a checkout and things like that. So if the book is not found, it says book not found. If the member is if you check to see if somebody is a member, and the person is not there, the person will be an unknown member. So the person can now register. Then you can now call the learn contains and call, like we said. So you run this also, that is done. So finally, you want to have a demo run for that. So you have LIB's library. What's the library called? That's city library. Then lib.add book. So you add this book with this 978. That's ISBN number. The title is Effective Python by Brett Slatkin, published in 2019. And the Python, it's about Python best practice, like some keywords, I think. Then you add these 3 books: Effective Python, Fluent Python, and Clean Code, by all these people with all this information. Then you want to register the member now. So the first member is M001, at least M002 Bob. Okay. And then you now have library size. So length of the library, that's the number of books you can find in the library. That's length. Then this one contains, so you are checking, contains book in library. So you want to see if these books and the ISBN are in the library. So that's how you go about that. Then you have print, search Python for all this. Then you can now do the checkout now for Alice, and then they print the borrower and all of these things. So if you run this now, you get the result. So library size is 3 because we have only 3 books in the library, right? Then if you have like more books, it will also have that. So I believe that this part, if we have a very robust area and we have to do it for a proper library, we may need to use like a kind of database to know the number of books instead of these single line declarations we made here, because that won't be efficient in that situation. But this is just an example. Okay, so contains book, true, right? Does it contain this particular book you're talking about? And the answer is true. And what is it? So it will search for the book. So it's something about Python. So that's effective Python and fluent Python. The borrower is M001, which is Alice, and returned true. So things like this. So with this, I come to the end of this video. Also, let me know how helpful this is for you. And if there's something you like when you try out, feel very free. If you have not subscribed already, you'll be missing a lot already. If you have subscribed, thank you so much. So if you have not subscribed, subscribe right now and hit the notification bell so you can always get alerted each time a new video is released. You can take it a step further by clicking on join so you can become a member of the channel, and that comes with some special privileges. For instance, if you have the gold access, you can have one-on-one interaction with me like that. All right, so that's how that works. Ultimately, don't forget to comment, like, share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing Python right. Bye.